welcome back. I want to talk about how we're using SolidWorks PDM to control the revisions as we're generating all this design data as we get closer to be ready to release our product. Real quick, there's just a couple big improvements I wanted to go over. Again, PDM is going to be controlling, making sure everyone has the right version, is working on the correct version. It's also giving us workflow to control the release of our products. A big one here is exploring multiple design ideas is a great way to help us refine our ideas and innovate them. It used to be a little trickier to do once we were in a controlled environment like the PDM vault. With the new branch and merge command, or a function, now we can take like our furnishing or our upholstered parts here, we can immediately branch off the original file. It's going to recognize the whole structure and make copies. We can add suffixes to it, and then we just generate those files. And now we've got 3 new branches that we can explore, change those around, get input, see which one we like the best. And then once we've chosen that best candidate that we like for release, we can then take that one, branch number 3, and we can merge it back into that original source file without blowing up the whole structure and causing problems like that. So when we open the original assembly now, you'll see that it recognizes that new file as our preferred candidate, and we were just moving on down the road now. So again, it's just going to help us eliminate some of those manual copy overwrite techniques that we got to do outside of the vault to do this kind of stuff. We don't want any roadblocks to exploring different ideas. So that's new for this year in PDM is the branch and merge function. All right, and one more here for PDM is we now have really good bi-directional communication between the revision table in our drawings and PDM. So let's see, let's take a look at how that works. So we've decided we want to make a change now that we've chosen this new cushion. So we're going to go right to our Rev Table, insert a new row. You'll notice the revision is an asterisk because it's not approved yet. That's controlled by our workflow in the vault. But we can put in our comments of what the change was about. It captures the date. And now when we check it in, it's going to take that revision table information. It's going to fill it out in our data card. Okay, so we don't have to enter that data more than one place now. And once it goes through our complete approval process in the vault, and it's approved, now it issues the right revision letter or whatever our scheme is, and now updates the revision table with that approval, updates all the notes, done. Again, just eliminating extra steps and entering data more than once, which just opens us up to making mistakes. All right, so now we're going to pay a little bit of attention to the electrical engineering disciplines. A little refresher, a new product last year, SolidWorks PCB. This was one hole in the SolidWorks design solution that we didn't have an answer for, was those designers of printed circuit boards. So we usually relied on a third-party piece of software, and the integration was lacking, shall we say. This is now just completely integrated with SolidWorks. PCB designers create their designs. We get 3D models generated right in SolidWorks based on those designs. Again, bidirectional control. It's a really great tool. I just wanted to go over a couple improvements there, again, that we are aware that our customers are asking for. IPC Footprint Wizard. Okay, so the scenario for this is if a manufacturer releases a new component, like a chip or something, and we want to integrate that, we want to use that in our board design. Rather than having to take their PDF or something and use a 2D program to draw it, we can just use a wizard now to enter the parameters from the manufacturer, and it will build like a standardized or IPC compliant footprint for the etching into the copper. Just again helps us move faster without having to have all that knowledge or have a mistake by not being to standard. And the same thing's going to work with schematic symbols now for those new components. We need to be standardized, and this speeds up the creation of those so you can then use them in your schematic by just stepping you through a wizard, getting the parameters, and it creates that standardized schematic symbol for you. All right, the last one here is variant collaboration. Use case for this would be if we plan on selling our product or in many markets around the globe. Those different places may have different power requirements. So the function of the board is going to be the same, but there may need to be a few differences there to handle those different power requirements or power supplies. When we import that into SolidWorks now, to build the 3D model, it's just going to give us those as configurations. Those different variants will be just listed as configurations that we can switch back and forth in SolidWorks. And so then again, on now the SolidWorks Electrical tool, this is a few years older. Just again, another big one. This is our tool that allows us to design a full electrical systems with a 2D schematic tool, and then that schematic file drives the placement of wires, cables, and harnesses in our 3D assembly. And what we can do this year, again, as these projects get very complex, these systems, multiple sheets and reports and tables, that it could get a little difficult if you want to take something like an attribute, maybe a wire color or something. You may have to change it in more than one place. And again, that just opens you up to making mistakes. Now you can control those at a very high level, at the global level, make one change, and it trickles down all throughout those complex projects. Again, just requiring less work of you and helping you avoid mistakes. All right, so now you've seen where we're getting our data together, we're getting ready to release. We've got all these great 3D models and design data, and now we got to get it ready for production. So we need to document it in 2D and 3D. We need to start making sure we can get the parts made. We need to get our technical communications ready so that the manual ships with the product, not afterwards. And we also may need some marketing material, and we're going to save some money by skipping the photographer. How about that? And I'll give it to Ryan.